And this is Expert Fonda and you are watching on YouTube. So today we are tackling a fantastic bandage search plus a greedy problem from Leetcode 2171, maximum number of tasks you can assign, right? And this one's a great mix of logic and optimization. So we will break it down step by step. So let's dive in. So as you can see, the statement is saying that you have n task and m workers, right? So as you can see the example, we have given task and worker in an array, and like this is saying with a ith task requiring task at I a strength to complete, and the strength of the each worker is stored in a worker also. So this is task and this is worker, right? And we have given pills and a strength. Okay, so you pause this video and go through the statement, right, so that you will understand, right? So let me continue. So each worker can only be assigned to a single task and must have a strength greater than equal to the strength of the required, right? Means that the worker can implement the task, right? Worker can complete the task if they have the enough strength. Like worker at J should be greater than equal to the task, right? Either it should be greater than or equal to. So this is the strength we have given for the worker, so he can finish the task if and only one if it is greater than equal to the given length at I and J, you can say. Okay, so additionally you have a pills, magical pills that will be increase a worker strength by a strength. So if the given number of pills are there, so he can take the pills of a strength, and if the strength is enough for the worker to finish the work, then we can finish that work. Okay, so our task is to return the maximum number of such tasks that is completed. Okay, so what is the problem intuition we have here, right? So what you have to do, you have to understand, imagine you have a set of tasks, right, and each needing a certain amount of strength and a bunch of workers. So each with their own strength level. You can also hand out limited number of magic pills that boosts a worker's strength by a fixed amount of the strength, right, you can say, and so he can finish the task. Okay, so your job, what is your job? Your job is to assign as many tasks as possible using these resources that we have given here as here, right? So there is many examples are there, you can go through here, right? You can pause this video from here and you can go through there, so you will understand what is the intuition of the problem is here. Okay, so what I understand from here, right, and you can relate it as much as possible, right? So the intuition is like a strong worker should ideally take on hard task. You got the point? Means the strong workers should ideally take on hard tasks. Let's suppose this is 3, right? So who is the you can say stronger worker, right? So these are the workers, these are stronger. Okay, right? And if you observe the example 3, right, in this case who is the strongest one? So to complete 10 there are 4 guys are here already that are enough to finish the work, right? But in this case if you see, the worker strength is 0 and he should finish 5 and 4 tasks, right? But they doesn't have the strength. So if the first one, if we'll take the one pill of a strength 5, he can finish the first work, right? Like that you have to think. Means the here doesn't have the enough examples, but you can think like what is the intuition here. So intuition is to find the stronger worker should ideally take on hard task. That's all, right? And the pills should only go to the worker who just barely need them. For let's suppose we have 3 to 1, right? Let's suppose we have 3 to 1. Okay, and if we are going to give this pill to these two, right, these two workers, means there's no benefit of that, right? So if we will use the pills of strength here for this worker because it's barely need them, right? So if we'll give this a strength to this worker, he can finish this work, right? And so the 3 and 3 can be finished by these two tasks, right? These two tasks can be finished by these two workers, right? Means the pills should only go to the worker who just barely need them. So don't waste them on workers who still can't do hard tasks even with a pill, right? And so we will use binary search to try assigning these k tasks. Let's suppose these are the k tasks, right? So we will use binary search to try assigning k task, and we'll check if it is feasible or not, right? So what we will do, we will do the step by step coding, right? So you can understand here, right, that I have done already, right? So let's break this down step by step to understand the code, right? So what we should do, let me go through the task here. So first of all, see the given things, right? So as I told you, we have given these things already in the example, and with the same things we have to return the number of what you can number of the completed number of tasks, right? Maximum number of tasks. Okay, so first of all, what we should do, we should we should sort these tasks and workers first, right? Why? So we can pair the hardest task with the strongest worker efficiently, right? So let's suppose if this is in the sorted order. So if this will be the sorted order, what will be the task? 1, 2, 3, right? And what about the worker? If we sort this will be already sorted. Let's for example, for this example, so 0 will get assigned to 1, and so the 0 worker needs a strength of pill, 1 pill, and he can finish that work, right? So it will be easy for him. Sorry. Sorry, I have a little cold. That's why I'm feeling that. So why we are sorting this, right? So why we are sorting this? Because if we will sort the task and workers, right, so we can pair the hardest task with the strongest worker efficiently, right? That we have understood. Okay, now what we should do, the next step is to uh, do the binary search on the number of assigned tasks, right? So the first step, we will do the sorting, and the next step, what we will do, we will do binary search on the number of assignable tasks. Okay, so the range is from 0 to minimum task, right? So what is the range? The low index of the array, if you remember the binary search, right? Binary search used to divide the uh, searchable array into half, right? And if we find the searchable on the mid, we used to return the mid. Otherwise we used to move the low, will move to the mid plus 1, means half we will discard, and half we will half we will discard, right? If we will find at the mid, means we will return the result, right? Like that. So the binary search here on the number of assignable tasks, and so the range will become what? From 0 to the 0 to mean task of mean task, you can say mean task, right? The task length and the workers length will become the mean, means low and high, right? So low will be 0 and high will become what? High will become what? Minimum between the length, minimum between the length, task length and the workers length. What is minimum? That we will take. Why we are talking about? Let's suppose if we have task is 3 here and work is only 2 worker is there, means the high will be only 2. You got this point? Let's suppose the task is here 3, right? But the worker is only 2. This 0 is not there, or 0, 3 is there, right? So the task length will be 3, but the worker length will be 2. So the high will be 2, right? 0 to 2. We will go maximum with 0 to 2, which is minimum that we will take, right? And so we will return the result once we will get it. Okay. Now we'll go with the low is less than equal to high, right? And for that, we will create this while loop, right? And we know how to find the mid in the binary search. To low plus high minus low by 2, we'll get the mid. We'll check the condition, these two condition, if and else, right? Means we'll assign can assign on this mid the task pills and this strength. Will, if we can do that, if we can assign that, we'll assign the mid at a result. Otherwise we'll update low, we will discard the half of the array will discard, and we'll move to the mid plus 1. And if this is not the condition, right, then we'll return, then we'll go to the else condition. We'll discard the second half, we will discard. This is the first half we are discarding, and this is the second half we are discarding. Okay, otherwise we'll update the result. So what is this can assign, right? So we'll create a greedy check function, right, can assign, and we'll pass a k. Let's suppose, what is this? Sorry. So from here to here is nothing but, you can say k, right? So k is the hardest task, you can say, right? We can provide the hardest task, and then we'll check can we assign this hardest task to this guy. If yes, we'll find the result, means the number of completed tasks, right? That can be computable. Okay, let me expand this. Okay, so now you can see here we have the another task, the can assign, right? So for k hardest task, right, for k hardest task, as you can see, right, we have used here k hardest task, right? So for the k hardest task, like we are calculating the mid here, right? So k hardest task, what we have to do in this greedy function, the first of all, we should try to find a worker who can do the task, right? And if not strong enough, then check if using up pills helps, right? So use the smallest available worker with pills to conserve stronger workers, right? Means first we will try to find the workers who can do the task, right? And for that we will write this piece of code. Means we'll create a available q, right, dq you can say, and j will be m minus 1, right? And what is m? The m is the worker's length, and p, you know, the pills, right? So we will create a for loop, right? And we'll go through all the you can say workers, for all the workers. Why? Because we have to find a worker who can do the task, right? So we'll go through the workers, right, in the decreasing order. Okay, we'll check the you can say through the while loop. We'll check the strength. If the workers at j plus the given strength is greater than equal to task at I. If it is, in the reverse order we go, right? Why we are going the decreasing order, right? Because if we have this worker, right, so the strength that we have given will go through like this, so that we can find the workers at j, right, is having the strength or not, right? If the strength is there, and then we are doing j minus minus worker at j minus 1, so we'll keep decreasing here, and we'll have our highest strength will be this side, so we can find the available worker, right? Means we are trying to find a worker who can do this task. So you can do like this. So available will get add first this one, and so this while loop will continue. We'll keep checking the strength, and we'll keep adding who can finish this work, who can complete the task, right? If available is empty, return false, that we cannot assign that this task because the worker doesn't have enough strength to finish this work, right? Then we'll check if at the available we have something, right? Means some workers is already there, so we can get from the peak, right? Peak, we will get from the peak and we'll check the task we are able to finish it. Yes, means we'll remove from the available, this worker has finished that work, we'll say. If not, means it is not available there, but we have, if p is equal to now, means the pills are no more, pills has been finished, so we return false. If pills, we have enough pills, right, then we'll go to the next step at line number 36 and we'll decrease the pills, right? Then we'll do again the pills poll first, we'll remove the available, and we'll keep continuing that for all the given task, you can say, right? Or worker, you can say, right? Then we'll return true, means we can assign or not, right? There is only two cases: if there is not available enough workers, or if there is no available pills, then we will return false. Otherwise, we can assign the task. If we have available workers, we can add that. If not available, we'll return false. If it is available, we'll do minus, we'll pull out. And if it is there, but the pills is equal to 0, we'll return false. Otherwise, we'll return pills minus minus, and then we'll do false out. And finally, we'll do that and we'll return true. Okay. So so the main thing about this method is to assign the task, right? We have to find the worker who can do this task, and if not enough not enough strength, right, then we'll check if we can use a pills to help him to finish the work, right? So we will use the smallest available workers, right, and with the pills to conserve the stronger workers. Okay, now you can put these things here in the code and you can see the task is completed or not. So let's continue again some dry run examples. So let's run through the quick example for the example 1. So we have task this one and workers is this, right? Let me move this one, this. Okay, so as you can see, we have task 3 2 1 and worker is 0 3 3, right? Pills is 1, strength is 1, right? So let's assign pills to the workers, right? So let's go with the 0, because we can assign or not, we'll go through this one, right? So let's suppose assign pill to worker 0, right? So a strength becomes 1, strength becomes 1, and after giving the, after doing this one, right, the workers at that this j is, workers at j is 0, right, and a strength is 1. So we have given a strength, now a strength is 1. So and task at I means some value will be there, right? So check, so does this task 1, right? So here if we will already sorted, so this will become 1 2 3, right? And so 1 can be finished now by the worker 1, right? And so yes, the worker 0 can finish this work, right? We'll go to the worker 2. So worker 2 is having 3, right? So worker 3 can finish 1 2 3, right? So he can get the work data 2, task 2, so he can finish the work, right? So worker 1 does the task. Now we'll go for the 3 through 3, so it is greater than equal to, means we have available 1, right? So like that we'll keep doing that, and yes, he can finish the work. So all the tasks can be finished by this one, right? And so our code is working fine, and we'll say let's go with the time and complexity, right? As you can see, right, before we wrap up, let's talk about the time complexity, right? So time complexity will become what? O of n log n plus m log m, because we are doing sorting here. As you can see, we are doing sorting here, right? And for the sorting, right, we will use n log n plus m log m, right, because we are taking two arrays, right, and like and for binary search, right, o of log m will take mean of m and n, which one is minimum, that will take for the binary search, and we'll check o of k with the efficient dq, because we are using the dq here, right, and for each operations. And so we have extra spaces that we are using here in the worst case for o of k for the dq in the worst case, right. So the complexity we'll talk about, it will become what, we can like o n log n log n, right, and plus m log m. So this will be your time complexity, right, and for the binary search you will use o of log, we can take, and we'll have two things, m in mean of m n, right, and we are taking the uh, uh, dq, right, and for that how many k we have, that will take, right, for each dq operations, right, and space will also take o of k. Okay, so let's summarize this one, right. To summarize this, use the binary search and try to find how many tasks we can assign, right, and for each try use a greedy dq strategy and use up pills wisely, so only when they help just enough. And if you found this video helpful, guys, don't forget to like, subscribe, and hit that notification bell, uh, and also comment below if you like the code, right, and if you want to see similar problem, right. So that's all for today, and let me know if you like this video. Thank you for watching this video. Please subscribe and please comment whatever you like or not like. Thank you for watching this video.